Alright, so in this video we're going to be doing notes on areas of different shapes. So first off is the square, obviously 4 sides that are all the same in length. One way you could do it could be length times width or base times height, but traditionally a square is indicated by side and the length of a side. So each side is 1s. So to find the area of it is side squared. Rectangle, you'll either hear it talk about with base and height or length and width, and its area is base times height and length times width. And one thing that's neat is that a parallelogram is actually nothing more than just a tilted rectangle. So it follows the exact same basic formula to find its area. Its height, though, sometimes could be also known as an altitude, for the distance from the tipmost 90 degrees to the bottom, or be inside of it. So be careful, because sometimes you'll give a measurement that's actually a side and that's not a height. A height has to go 90 degrees to the base. Alright, so let's move the paper up. Next we have a rhombus. And the rhombus can actually follow very similar to, again, a parallelogram. The difference being the parallelogram just needs to have 2 pairs of congruent sides. A rhombus is more like a square where all the sides are the same length. So in that situation, it's side times height, or could use base times height. So it's kind of a mix between a square concept and a parallelogram. The height, again, is either going to be an altitude on the outside or on the inside. And don't confuse the height with a side length if it gives you a measurement along this side here. Another way that you can also find the area of a rhombus is what's called using its diagonals, or lines that connect opposite vertices. And so diagonal 1, diagonal 2, it doesn't really matter which diagonal is which, it's just indicating the difference between them. So one way that you can also do it is diagonal 1 times diagonal 2 divided by 2. And that's its other way to find its area. So along those lines you also have the kite, which is similar to the rhombus, but again a rhombus has all 4 sides the same. A kite has a set of congruent links and a set of congruent links, but still has 2 diagonals attaching and connecting opposite vertices. So you have a diagonal 1, diagonal 2. Again, it doesn't really matter which one is which, as long as they intersect at a 90 degrees and connect the vertices. So it follows the exact same formula as a rhombus of diagonal 1 times diagonal 2 divided by 2. So then we have the triangle. Normally you'll see it in one of these 3 ways, with your height being either on the inside, will be a side as long as the side is 90 degrees to the base, or also be an altitude possibly on the outside here. And our formula is base times height divided by 2. So hopefully you kind of noticed a pattern on some of those shapes and how to find their formula. Alright, go to the next page. continued, and we have the trapezoid. These are the two common ways that you'll ever see a trapezoid. And in these situations, the height is either going to be, again, on the inside with 90 degrees to the base. Do not confuse the height with a side length. It has to be 90 degrees from the base. Or the height could actually be the side itself, as long as that side is 90 degrees with the base. If you notice, we have a base 1 and a base 2. And the bases are the flat parts on top or on bottom. And it really doesn't matter, it's just base 1 is one of the bases and base 2 is the other base, the second base. So to find the formula, it's kind of more like an average, where you're going to add them up and divide by 2, and then that average you're going to multiply by the height, is one way to think about it, that you need to add them. Very commonly, that's an area where students have a tendency to put the wrong operation here. But if you think of it kind of like an average base between the two of them, add them up, divide by 2, and multiply that by the height. Or base 1 plus base 2 times height divided by 2. Almost like a triangle as well. And you can envision that as if I extended these lines out, I would in fact get a triangle that's been cut off at some point. So it still follows that initial base times height divided by 2 concept. Okay, next is the polygon. We're going to move up. So the polygon has quite a few different pieces to it. And what we have here is an introduction to a word called the apotheum. The apotheum is the distance from the center to the side at a 90-degree angle. And also we have our traditional S side length, and then also N is a new variable to represent the number of sides. So initially what we're going to be doing is, you can see we do apotheum times side divided by 2, which finds the area of one of these little triangles, and then we multiply that by how many sides we have and basically fill in with several little triangles. So there's 1, 2, 3, 4, 5, 6 triangles in a hexagon or a 6-sided shape. Since it's multiplication, you can also rewrite it as number of sides times apotheum times side divided by 2, or SNA divided by 2, SAN divided by 2, and all of those are the same concept. You might also see it in terms of what's called the perimeter. And remember, perimeter is the distance around a shape. And so with a regular polygon, where all sides are the same length, the perimeter is the same thing as side length times number of sides. So side length plus 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 plus, or basically S times 6 in this situation. So when you have the perimeter already being the same thing as the S and the N being multiplied together, you can actually rewrite the area as the perimeter times the apotheum divided by 2, as the perimeter is the same thing already as side times number of sides. So that is an alternative formula, especially if they give you the perimeter, how you can use it to find other pieces of information. Moving up, we have the circle, which is either pi r squared with r being my radius, or the area is diameter divided by 2 first to find our radius, then squared times pi. We have semicircle, which is basically half of a circle. So you'd find the area divided by 2, or again take half of the area of a circle given the diameter. Last but not least is our oval, which has a radius and a radius, one on the short, one on the long, at a 90 degrees, radius 1, radius 2, and so the area is pi times radius 1 times radius 2. Alright, those are the formulas for the areas of initial shapes. I hope this helped.